Let's go back 7 years to 2012. Some of you are making the transition from middle school to high school. Most are secretly hoping that the world will end on December 21st. Odds are you remember a lot from 2012, and it's because humans have an extraordinary ability to time travel in our minds. We form an infinite number of memories. And what about when you're driving down an unfamiliar road, and when you make it to the end, you automatically know exactly where you are? How do we form that initial memory? How does it work? These are questions researchers and neuroscientists have been asking for centuries. We've gained cellular theories like the Hebbian synapse and long-term potentiation and many others, but neuroscientists have always looked to neurons for answers because glial cells didn't fire action potentials, and they were just thought of as glue. They provide structure, nutrients, waste removal, but that was about it for the longest time. Though recent decades, many researchers are starting taking a closer look at one specific type of glial cell, the astrocyte. Long-term potentiation is an important theory that states that neuronal firing patterns strengthen as they are used. Glutamate and its receptors are known to play a role in this theory, but what about astrocytes? Let's look into a model that can explain how this may work. Controlling extracellular glutamate levels in this way allows astrocytes to modify neural communication and, most importantly, prevent toxic levels of glutamate from accumulating in the brain. Blood carries nutrients and oxygen up to the brain for the brain to use, but doesn't meet with neurons directly. Astrocytes form the blood-brain barrier. And when a neuron needs energy, astrocytes convert glycogen or glucose to lactate for the neuron to use. This process also aids in long-term potentiation by giving the neurons more energy to fire more action potentials. To conclude, long-term potentiation is an important component of memory formation and learning. Neurons have been thought of as the thinking brain for most part of history, but astrocytes certainly have an important purpose. We went through how astrocytes might control glutamate levels in the brain and how astrocytes can energize neurons to facilitate LTP, or long-term potentiation. There is more left to figure out in this field of science, but there is also lots of promise in understanding what actually happens in your brain.